For these problems, we are given some information about the zeros and some other information about a polynomial, and we want to form the polynomial. So that means we want the equation. So for this first one, we have a 0 at -2 with a multiplicity of 3, a 0 of 5 with a multiplicity of 2. Now before I even look at the rest of information, I can get some of my polynomial from that. If the 0 is -2, the factor is x plus 2, the opposite sign. And then the multiplicity is the exponent for that factor. We have another 0 at 5, so I get another factor. Factors have to be multiplied together. The factor of 5, the 0 of 5 would have a factor of x minus 5. The multiplicity is 2. Okay, so this is taking care of this information. Now I need to look at the rest of the information to see if I have everything I need. The overall degree needs to be 5. And yes, I've got that, because here I have 3 plus 2 would give me my overall degree of 5. The leading coefficient is -9. Right now, my leading coefficient is 1 because I don't have a number here. So I need to multiply this by -9. And this is fine. Don't worry about trying to distribute that out. Leave it in this factored form. Okay, so then what about the second one? There are 3 different zeros that we're going to start with. The first one has a 0 of the number 0. So I'm going to first write the factor as x minus 0. The next 0 is at -4, so the factor will be x plus 4. And again, these have to be multiplied together. The next 0 is at 3, so the factor is x minus 3. Now, I can simplify a little bit. I'm going to rewrite this as x at the end, and you could do that directly at first if you see that. But now, what about my other information? I'm supposed to have a degree of 4. Well, right now, because I have each of these factors to the first power, my degree is just 1, 2, 3. So somehow I need to change the degree. Now, I wasn't told the multiplicity like in the previous one, so they don't tell me directly, here's the one that has to have a higher degree, because I need one of these to have a degree of 2 in order to get a total degree of 4. But look at this info. It touches the x-axis at x equals 3. To touch the x-axis, I have to have an even multiplicity. That means the power of my factor needs to be even. So this is the one that must have the square. And now my total degree is 1, 2, 3, 4. I have all of the information from the problem. And again, the only thing that I'm going to do to simplify is rewrite that x minus 0 as x. Okay, and the last one for this type, I've given 2 zeros at -5 and 8. Start with x plus 5, x minus 8. The total degree is 7. Oh, so let's see. Right now I only have a degree of 2, so I'm going to have to really adjust the exponents of these factors to get that degree. What other info do I have? It crosses the x-axis at x equals 8. So to cross the x-axis, I need to have an odd degree. Now, there are multiple ways that I can get an overall degree of 7 where this one factor has an exponent that is odd. The easiest is to just leave that as 1 and make this one 6. That works. But there are other options. I could do my even power here as, my odd power here as 3, and then for a total degree of 7, that would make this one 4. Or I could make my odd power 5, and that would leave me a total of 2 to get a degree of 7 for the entire thing. And notice that's the last one, because if I try to go to the next odd power, that would be 7. Well, but then I don't have any exponents to put here, so that means the factor x plus 5 would have to be gone, but that would contradict needing a 0 at -5. So any one of these 3 will work, Notice I also could put any number I want in front for my leading coefficient. So there are an infinite number of correct answers for this problem. The key is that you need an odd exponent on the factor x minus 8 and an even exponent then that would where the multiplicities would add to get 7.